This in two different ways. I'm going to show you all the formulas, and I'm going to try to make you realize that there really are just like 3 formulas, truly. But you can write them all down. Volume, I'm going to let you write volume of a cone. So on the review day, I'm going to make it very clear what's allowed on your formula sheet. Because if you put too much on your formula sheet, you lose points. Right? Because obviously that's not fair to everybody else.
Why would you don't do that formula sheet for us so everybody will know what was supposed to be in the test?
Oh, no.
If you
On the day of the review, we'll talk about what should go on the formula sheet, right? I'll put them up on the board even. But what should you do, since I write so horribly? You should really go back in the book and just make sure you get them all. And one thing I want to point out to you, if you look at the end of a chapter, let's see if I know what I'm talking about. They summarize, like on page 601.
No, what I was trying to say, so
there's all the
will know.
formulas that they talk about.
So everybody will know really what we needed, because I will not want to do so much or maybe little, and then.
On the day of the review, I will put exactly what you're allowed to put in the formula sheet.
Oh, cool.
Right?
Thank you.
Okay. So let's start off with the easiest shape for volume that there is. And most of you guys probably haven't memorized already what it is. Now, how many guys have any trouble drawing in 3D? All right. So one thing you can do for yourself
I do figure sticks.
is you can do this. See how to connect the corners? You guys ever seen that?
Yeah.
Okay. Just draw 2 squares and connect the corners. Personally, I don't like that because then you get all this overlap. So connect those corners, connect those corners, connect those corners, connect those corners. 3D. Now let me see if you guys get this. Where are my art students at? Who knows all about the vanishing point and all that kind of stuff? So if you do that specifically, you got to pick a point to be the vanishing point. Screw it. You can do it like this too. See? Like that. Right? 3D is not easy to draw in, obviously. Right? My art students, if you're just starting out, you know what I'm talking about. So let's work with this guy. I don't like all this middle stuff in here, right? So let's say this is the length, this is the width, this is the height. Let me start off with this. Now with this guy, I can then put the interior in. What is the area of the base?
The length times the width.
Cool? Because the base is just a rectangle. That was nice. Base is just a rectangle, so it's length times width. Is that cool? Now can you imagine now, let me think. Do you guys remember these things that were called records?
Yeah.
And they came in these sheets, these square
Finals.
sheets, the vinyls, yeah, good. Right, have you ever seen High Fidelity?
45.
So if you stack up a bunch of records, the area of this thing, when it's in its sheath, the area would be just the area of that square, that rectangle, right? Should be a square. So if you stack a bunch of them up, you add up all the areas of those, and that basically equals the volume of that thing, right? So how many here do I have stacked up, really? This many. I'm trying to make you see how this works. And actually, this idea holds no matter what shape the base is. Because does the base here really have to be square or rectangular? Couldn't I make the base circular and then make like a cylinder? Right? Like stacking a bunch of pennies? Or those things, what do they call them? CDs nowadays? Those or even records. When you take them out of the damn thing, they're circular, right? So here the volume, of course, some of you guys already knew this before. What's the area of the volume of this cube?
Length times width times height.
Length times width times height. Right? It's officially called a rectangular solid. If all the sides are the same length, it would be, of course, a cube. Right? How we doing? So most of us probably knew that already. If you didn't, I'm hoping that kind of makes sense. You find the base and you just multiply by how tall it is. That's going to be how much that base goes through. That's going to be a total of how much volume it goes through, right? So, for example, let me just show you how this works on a different shape. If I have a cylinder, watch, you draw like a little ellipse. Like that, right? You can put the back in there. How are we doing? So this is me looking down on a cylinder, right? What's the area of the base going to be? What I have to tell you is, say this is R.
The radius.
area is
What was it, pi times radius?
almost.
So you have two circles and then
Pi times r squared.
Just the area of the base, that's all I want.
Pi
Pi times r squared.
Pi r squared, right? The base is a circle. Right? And again, if I turn this thing this way, you'll see it's a circle, but can you see the rest of it? No. So let me turn it back that way. There we go. It looks like an ellipse because I'm looking at it. Is everybody cool with that?
Yeah.
So it is a circle, it's a circular base. So the area of the base is that. It's h tall, that's the height. So you're doing the same thing we just did over there. If I stacked a lot of pennies up, and each penny has an area of whatever, and then I stack a bunch of them up, how do I figure out the volume of that goes through is multiply the area of a penny times how tall it is. That'll be the volume that passes through. So the area base is pi r squared, was the volume of this cylinder. The area of the base times the height.
Pi.
That's the volume of what's called a right circular cylinder. Good God. It's right because I have a right angle here. You can imagine it gets a little weird when it's tilted, like Leaning Tower of Pisa, right? It gets a little weirder then, but let's just deal with right circular cylinders. I mean, does that make sense? Look at these two formulas though. Look at that formula, look at that formula. Do they look like they have anything in common? You might say they have H in common, but I mean fundamentally, they're totally different things. But no, area of the base times the height. Bam, right? What if I had a triangular base? I would just find the area of the triangle times how tall the damn thing was, right? Like if I had a pump tent. You guys know? So we're getting a lot of practice with our, because I need it, obviously. There's my pup tent, right? There's the flap. How we doing? There's a little dude outside.
You got kicked out.
Right? They're on top of the ruins there before the vines come up and kill them. I saw that movie the other day, so it's free. So let's say this is, what's going to make sense here? Let's say it's 7 foot tall, and it's 8 feet across, and it's 10 foot long.
How come mine doesn't look like yours?
Say again, sir?
Mine doesn't look like yours.
That's fine. It looks about the same, so that's all we need.
The height is 10.
Real quick thing about drawing these. Notice that these have to be parallel to make it look like that's... Anyway. So what's the area? And do you guys see how this is just like this? I've just turned it over, right? So this is still the base, isn't it? And notice how the base is the shape that's repeated throughout. Here the base was this circle. Why? Because it's repeated throughout.
So the height is 10.
Height is 10
Yeah.
of the whole thing, right?
Yes.
Now what's the area of this base? What's the area of this?
1/2 base times
1/2 the base times its height. Cool. Hopefully you're not freaked out about there being two heights in a way here, right? There's the area of the base and then times the length here in this case because it's sitting on its side. 1/2 the base times the height. So what's the area of that triangle? Area of the base? 28, right? 1/2 8 times 7, this will be 28 square feet. How are we doing? Now how do you get the volume of the whole tent?
Just add the height.
Yeah, so the area of the base is 28 times how much that's repeated. The triangle is repeated 10 feet worth, right? So I get 280 what?
Feet squared.
Careful. Feet cubed. Because what do I have here? Square feet times 10 feet. What's feet squared times feet? Feet cubed.
Because it has when you see a whole number, it has the power of 1. So when you're multiplying the powers, it's
Yeah, it's just like good old x squared times x. What's that?
x to the third.
X to the third. So feet squared times feet is feet cubed. Same idea, exactly the same idea. Volume always has to come out in cubic units.
3D.
3D, I love it, because you get 3 dimensions. Area is 2-dimensional, that's why it's squared units, right?
So the first step then is to find 1/2 the base times the height so that you can get your feet squared. And then to find the volume, you take the feet squared, multiply it by its height, and come up with the feet cubed.
Yes, cool, okay, good. Yes, sir.
Is it possible for you to draw anything else above cube? So let's take to the fourth power.
I love it. I love the way you're thinking. Have you guys ever heard of something called a hypercube?
Yeah.
Have you guys ever seen those movies, Cube? That Cube and Cube Zero? And
Oh, yeah.
you never seen those movies?
No.
They're pretty good, actually. Hypercube would be something that has 4 dimensions. Now, we're not going to obviously get into all that here, right? Because 3 dimensions is normally enough. Do I have to separate you two? All right. Don't make me turn this car around. But I like what you're thinking about. That's not possible, though, right? It's hard enough to draw a 3-dimensional shape on a 2-dimensional board. So to draw a 4-dimensional shape, you'd have to somehow draw it here, right? So yeah, let's not go there. I like the way you're thinking, because there might be as many as 11 dimensions in the real universe, so who knows. But we won't go there. Let's not go there. So let me just show you what we got so far, okay? We've got right circular cylinder was this guy. We've got the most basic one is this guy. This guy, I'm not going to make an official formula out of him, because it would look disgusting and have 2 different H's, wouldn't it? You have like a capital H and a small h.
What would be the length, right? The length.
But it all depends on if it's sitting on its side or not, right? So you can imagine, I hope you can imagine, I could make like a trapezoidal. Looks like I can, all right.
Now you're strong, that's hard.
I really want you to see this. This is not any harder than that or anything was. All I have to tell you is enough for you to find the area of the base. So let's say this thing is 10 meters long, and let's say it's 4 meters high, and this is 6 meters, and this is 2 meters.
Well, with that 3-dimensional shape, you actually have 4 parallel lines. You have the set.
No, let's not go there. What's the base? What shape is the base? Trapezoid.
So the trapezoid formula.
It's a trapezoid. Why is it not parallelogram? Because these two are not parallel. Right? Do we know the formula for the area of a
Yeah.
trapezoid?
Yes.
And then the only new step now for the volume is multiply what you get there by 10, because that's how often it's repeated. Do you see what I'm saying? So I don't need a volume formula for each of these stupid things. What is the formula for something that has a repeated shape? And this is actually called a prism. Anything that has a repeated shape through it is called a prism. Area of the base times the height. And what we normally do is we say big B is area of the base. That is a big old B, yeah. Times height. So this is area of the base. So one thing is the formula helps us keep it together. But do you understand where the formula comes from? It's a very simple idea. People get turned around here when they see the B, they'll put like 6 in. 6 times 10 is 60, yay. No, this big B is the area of the base. It's the only way it makes sense. I need to end up with cubic units, right? So what would the area of the base be here? It'd be 1/2 times the height of it.
4 times B1. Or
So it'd be 1/2 times the height is 4. What's B1 plus B2?
2 plus 6.
2 plus 6, so 8. How are we doing so far? 16. 16 what?
Meters cubed.
Meters
Squared.
squared. So that's the area of that trapezoid. That would be the end of a problem in section 9.3. What does 9.4 do to me? Oh, I got to multiply by one more number. Ooh.
So 160 meters cubed.
So now I can plug it into this formula. Volume equals big S BH. Big S B is 16. H
It's 10
is 10. So my volume of that thing is 160
meters cubed.
cubic meters. I love it.
So
I got it.
the first.
Like I said,
The
9,
base
3,
is-
and then 9.
Base is a trapezoid. So this is all work for the
2 and 6 are the bases.
area of the base.
But you have 2 bases already. The 2 and the.
What's the base of the shape? A
Okay.
trapezoid. What's the base of the entire shape? A trapezoid.
The base is 6, right?
The base of a trapezoid is 6 and 2. But do I have a trapezoid that I'm looking at? No.